This is Notes 8-7, Solving Inequalities. The objective is to solve inequalities containing addition or subtraction. Solve inequalities by multiplying or dividing by a positive and negative number. The Common Core state standards are listed in the mathematical practices. Solving inequalities by adding and subtracting is the first section. It says solving inequalities can be solved by applying the same steps as solving equations. Solve the following inequalities algebraically by showing all steps. Check solutions. The first inequality says x minus 21 greater than or equal to negative 26. We want to find out what x is. Number 1 says x minus 21 is greater than or equal to negative 26. We want to find out what x is. So since it's x minus 21, we can add 21 to both sides to get the x by itself. Negative 21 plus a positive 21 is 0, and any number or variable plus 0 is that number or variable. So it's x, bring down your sign, greater than or equal, and now on the right hand side we have negative 26 plus 21. So since we have different signs, we take the sign of the negative, which is 26, so our answer is negative, and subtract 26 minus 21 is 5. So our solution is x greater than or equal to negative 5. That means that any number equal to negative 5 or greater than negative 5 is a solution to make the inequality true. So to check it, pick a number greater than negative 5. Don't pick equal to it. So any number greater than negative 5, and a nice easy one always to use would be 0. 0 is greater than negative 5. So 0 minus 21 greater than or equal to negative 26. Well, 0 minus 21, or we can change it to adding the opposite, 0 plus a negative 21 is negative 21. Is negative 21 greater than or equal to negative 26? And it is greater than because it's closer to 0. So x greater than or equal to negative 5 is your solution. So on your graph at negative 5, since it's equal to, it's a closed circle, our inequality is on the left. So we go in the same direction as our inequality symbol, which is pointing to the right. Number 2 says y plus 1 4/10 greater than or equal to 7. So we want to find out what y is equal to. So we are going to subtract 1 4/10 from both sides. We're going to add a decimal point and a 0, so we can line up our decimal points. On the left-hand side, since we're subtracting 1 4/10, we're left with 0, so we're left with y. Bring down your inequality symbol, greater than or equal. And we have a subtraction problem. So since we can't do 0 minus 4, we're going to borrow from the 7. So we have 10 minus 4, which is 6. Bring down your decimal point, and 6 minus 1 is 5. So our inequality is y greater than or equal to 5 6/10. So on 5 6/10, which is a little bit more than 5 1/2, so we do a closed circle, and I'm just going to label since it doesn't fall right on 5 6/10. That's 5 6/10, and since your inequality is pointing to the right, your graph goes to the right. So to check it, you would pick any number greater than or equal to 5 6/10. So let's pick 6. 6 plus 1 4/10 is that greater than 7. So when we add, we get 7 4/10, and that is greater than 7. So 5 6/10, or any number greater than 5 6/10, is a solution. Number 3, negative 5 less than x minus 2. So the first thing we can do is we locate our variable. We're subtracting 2 from it, so we can add 2 to both sides. Right-hand side, we're left with 0. So 0 plus x is x. Bring down your inequality. Now on the left-hand side, it's negative 5 plus 2, so we take the sign of the larger and subtract. So since our variable is on the right, we're going to flip everything around. The x goes to the left. Our inequality is open to the x, so we want to make sure that we flip it around. It's still open to the x, and bring down your negative 3. At negative 3, you're going to have an open circle. Your inequality is pointing to the right, so the graph goes to the right. To check it, we are going to substitute any number greater than 3. Let's pick 0 because it's nice and easy. -5 less than 0 minus 2. We can change subtraction to adding the opposite, so we're left with -5 less than a -2. Since -2 is closest to 0, it is actually larger than -5, so this is true. So x can be any number greater than -3. Section 2 is solving inequalities by multiplying or dividing. It says when you multiply or divide each side of an inequality by a negative number, the inequality symbol must be reversed for the inequality to remain true. So in the first one, 7 greater than 1, it is true. If we multiply this by a positive number, so I'm just going to pick any number, 2, because it's nice and easy, I have 14 greater than 2, which is true. But if you multiply by a -2 on both sides, we get a -14 greater than -2, and that's false. Okay? When you multiply both sides by a negative and don't flip your inequality sign, it's not true. -14 is not greater than -2. But if we do this problem again and we multiply both sides by a -2, so I'm left with -14, but this time flip your sign, so reverse it. It's pointing to the right, flip it so it's pointing to the left, -2. Is -14 less than -2? That is true. So you need to make sure that whenever you're multiplying by a negative, you have to flip the inequality symbol. That means you have to flip the inequality so it's going the opposite direction. It says solve the following inequalities algebraically by showing all steps, then graph and check solutions. So we have a one-step inequality here. It says 6x less than -18. So to get the variable by itself, we have to look at the number that's attached to your x. It's multiplication. So we undo, we divide by the same number. Well, the number that's in front of the x is positive. So we're dividing by a positive 6. You do not have to flip the inequality around. So 6 divided by 6 is 1. So we're left with x less than, and -18 divided by 6 is -3. So on your graph at -3, you're going to do an open circle. The inequality is pointing to the left, so our graph needs to go to the left. So any of these numbers on your graph, -4, -5, -6, and so on, those are all possible solutions. So to check your answers, we can pick any of those numbers. So let's pick -10. So 6 times a -10, is that less than -18? So 6 times a -10 is -60, and that is less than -10. Number 2, we have -2/3 x greater than or equal to -6. So on your variable side, there is a negative. So that means we're going to have to flip your inequality sign around. We need to reverse it, but we're going to do that in the last step. So first we're going to multiply both sides by the reciprocal because it's a fraction. What we do to one side, we have to do to the other. We can put a 1 underneath the 6. Everything on the left-hand side cancels out. A negative times a negative is a positive, so you're left with 1x or just x. On the right-hand side, we can cross-cancel the 2 with the 6. You're left with 3 and 1. Multiply a -3 times a -3, which is 9. Now, your inequality symbol, we said we need to flip it, so it needs to go to the left. So your solution is x less than or equal to 9. So at 9, it's going to be a closed circle. Our inequality is pointing to the left, so your graph goes to the left. So everything that's being graphed to the left is all possible solutions. So always pick nice easy ones like 0. So to check it, it's -2/3 times 0 greater than or equal to -6. So any number times 0 is 0. So 2/3 times 0 is 0, greater than or equal to -6. And since 0 is greater than or equal to -6, it's greater than any of those numbers graphed on that number line is a possible solution. Number 3 says -2 less than or equal to x over -3 and 5/10. Your variable's on the right, so we want to undo the division by multiplying both sides by -3 and 5/10. So on your right-hand side, we can put that 3 and 5/10 over 1. You can see that you can cross-cancel the negative 3 and 5/10. So you are left with x. Our variable is on the right, and we did multiply by a negative, so we're going to have to flip our inequality around, so it needs to be pointing to the x. Negative 3 and 5/10 times a negative 2, so 2 negatives gives us a positive, and 3.5 times 2 is 7. Since the variable's on the right, we're going to rewrite it so the variable's on the left. We have to flip the inequality symbol around so it's still pointing at the x, and bring down 7 so it is on the right. So you're graphing x is less than or equal to 7. So at 7, it's going to be a closed circle. The variable, since the variable's on the left, the inequality is pointing to the left. Our graph goes to the left. So any solution that's being graphed is a possible answer. So to check the solution, we can pick any number that is graphed on our number line as a possible solution. Anything less than or equal to 7. So we have negative 2, less than or equal to. And again, since 0 is a possible solution, we can put that in 0 divided by negative 3 and 5/10. So we have negative 2, less than or equal to, and 0 divided by 3 and 5/10 is 0. And negative 2 is less than or equal to 0, so this is true. Section 3, solving two-step inequalities. Solve the following inequalities algebraically by showing all steps, then graph and check solutions. Number 1 says 8 minus 4p greater than 20. Since the variable is the second term, we're going to change subtraction to add in the opposite. So we are going to subtract 8 from both sides of your inequality. So we're left with negative 4p greater than 20 minus 8 is 12. Now we're down to a one-step inequality. We need to get the p by itself. So what's attached to it is a negative 4. So we're going to divide both sides by a negative 4. Because we're dividing both sides by a negative 4, we need to flip the inequality around. So p is less than, and 12 divided by a negative 4 is negative 3. So on your number line at negative 3, you're going to do an open circle. The inequality symbol is pointing to the left, so we're going to graph to the left. So all our possible solutions are anything to the left of negative 3, which would be negative 4, negative 5, negative 6, and so on. To check it, we can substitute in any value that has been graphed. So we'll pick negative 10. So it's 8 plus 40 greater than 20. And 8 plus 40 is 48, and that is greater than 20. So all those solutions will work. Number 2 is b divided by negative 3 plus 9 greater than or equal to 8. We want to find out what the b is, so we need to get rid of everything attached to the b, so we're going to subtract 9 from both sides. So we're left with b over negative 3. The 9's cancel out to 0, so we can eliminate that. Bring down your inequality symbol, and 8 minus 9, or 8 plus a negative 9, gives us negative 1. Now we need to multiply both sides by a negative 3. Since we're multiplying by a negative, we got to flip the inequality symbol around. Our 3's cancel out, so we're left with b flip, so less than or equal to 3. So on 3, you're going to do a closed circle. The inequality is going to the left, so our graph goes to the left. So to check, we can use any number that's been graphed. Since 0 has been graphed, we'll use that. So it is 0 divided by a negative 3 plus 9 greater than or equal to 8. 0 divided by negative 3 is 0. Bring everything down. 0 plus 9 is 9, and 9 is greater than 8. So this is a true solution. All right, on the little box off to the right, it says words to symbols. Remember, at most translates to less than or equal, while at least translates to greater than or equal. Problem solving. Macy is making each of her 7 friends a bracelet. In addition to charms, she needs 1 package of wire for all the bracelets. The wire is $6. She does not want to spend no more than $45 on the bracelets. Find the maximum cost for each bracelet. So Macy is making bracelets for 7 friends. She also needs to buy a package of wire that is $6. She does not want to spend no more than, and no more than translates to less than or equal. That means that she doesn't want to go over $45. The most she wants to spend is $45 or less. So that would be less than or equal to $45. So we want to find out the cost to make each bracelet. So our cost is our unknown. So we have 7 friends. We want to figure out the cost for each bracelet, and we know that she's going to spend $6 for the wire. So to get the variable by itself, subtract the $6 from both sides. That gives us 7C less than or equal to 39. Now we want to divide both sides by 7. So we're left with cost less than or equal to. You can use your calculator to divide, and when you divide it out, you get $5.57, and that is rounded. So the cost for each of the bracelet is no more than $5.57 for each bracelet.